So welcome everyone. So in the last lecture, we have seen how we can design a common bus system with the help of multiplexers, right? So in this class, we'll see one problem of designing a common bus system, right? So this is the problem. So what we are having in this problem, we have a bus organized CPU having 16 registers. So we'll see what are the key data we are having. So we are having 16 registers, right? And the size of each register is 32 bits. So these are the two very important things in this, right? And what else we are having? We are having an ALU, so that is arithmetic and logical unit, which is responsible for performing operations. And then we are having a destination decoder. So what is the use of destination decoder basically? So this destination decoder will actually put the result in one of the registers. So it is responsible for putting the result in one of the register, or you can say it is responsible for selecting selecting one of these 16 register where the result of the operation will be stored, right? So what we are having two input values of 32 bits each, right? Then there is some operation that needs to be specified, and there is some decoder value which will select the destination. Okay, all right. So in the first part, what is being asked, how many multiplexers are there in the bus A? Or see, we are having two buses. So for any binary operation, we need two values. So we are having bus A and bus B. Okay. So what is the, how many multiplexers are there in one of the bus? How many multiplexer are there in bus A? And obviously bus B will also have same number of multiplexer, and the size of each multiplexer in both the buses is going to be same, right? So how many multiplexer are there in a bus? So if you remember from the last lecture, we have already seen total number of multiplexers, right? One multiplexer is giving us a one bit on the common bus or on the common bus line. So for this multiplexer, uh, to get 32 bits on the common bus line, we need how many multiplexer? So number of multiplexer is equals to number of bits in each register. So it is going to be 30, 32, right? So that is one thing we have got. Then what is the size of each multiplexer? So size of each multiplexer will actually depend on the total number of register, because one multiplexer is getting one bit from each of the register, right? So how many bits it will get? It will get the bits equals to the total number of register. So obviously the size of each multiplexer is going to be 16, that is equals to total number of register cross 1. Why we are putting 1 here? So 1 is the output and 16 is the input. Okay. So this is for part 1 is over. Then how many selection inputs are there in multiplexer A and multiplexer B, right? This is actually multiplexers on bus A and multiplexers on bus B. Okay. So obviously, as we are having the same number of multiplexer and same size is there, so number of selection input is also going to be same. So selection input actually depends on the size of the multiplexer. So you have to see here. So size of the multiplexer is 16, right? And 2 raised to the power 4 is actually 16. If you remember from the last class, so we are having, if we are having 2 raised to the power n inputs, then number of select line is going to be n. So here we are having 2 raised to the power 4 input. So number of select line is going to be 4. So answer of this part is 4. Then how many inputs and outputs are there in ALU for data? So data we are getting from 2 bus, including input and output carry. So if I talk about input, so how many bits I am getting on bus from bus A? 32 bits I am getting, right? Then for bus B also 32 bits. So I can put like this: two buses are there, so 2 cross 32. That is the total number of inputs I'll be having. Plus there is a input carry, so I'll add 1. So it is going to be how much? 65. Yeah, right. So these are the number of inputs. Then then we talk about output. So obviously on output again I'll be getting some number of bits. So how many bits are there? So I'm adding 232 bits of data. So obviously the result will have 32 bits. So it is number of output lines is going to be 32. That is the result. Plus there is output carry also. So it is going to be 33. Right. Then it is saying formulate a control word for the system if the ALU has 35 operations. Now what we'll be having in control word? So in control word we'll be having 4 things. One is for selecting A bus, then for selection of B bus, then for then there is a destination selector which will select with the help of destination decoder. Now what is the size of the destination decoder, right? That is the question. So size of the destination decoder will actually depend on the number of register, and 16 register are there. So obviously the size of the destination decoder is going to be 4 cross 16. Remember this thing. Any decoder will have n cross 2 raised to the power n configuration, right? So n is the number of input line and 2 raised to the power n is the number of output line. So the size of the input of the input of the destination decoder is going to be 4. And what is the last thing? That is the number of operations. So there are 35 operations. So how many bits we need? So if I put it in the form of 2 raised to the power n, so I need to select 6 bit. That will actually serve my purpose. Because if I take 5 bit, then 2 raised to the power 5 is going to be 32. So it will not serve my purpose, right? So I need to have 6 bit to specify one of the operation out of these total 35 operations. So it is going to be 64. So 64 comes under this 35 comes under this 64. So this will actually serve my purpose, right? So this is the result you can see here. The total number of multiplexer that I have already told you equals to the number of bits in each register, 32. For bus A as well as for bus B, both the number of multiplexer and the size of each multiplexer in both the buses is going to be same. Then size of each multiplexer will actually depend on the number of registers. So total 16 registers are there. So size of multiplexer is 16 cross 1. Number of selection input will depend on the size of multiplexer. So it is going to be 4. Why? Because 2 raised to the power 4 is 16. Number of inputs in decoder, that will depend on the number of registers. So total how many registers are there? 16. So we need to have a 4 cross 16 decoder, right? So configuration is n cross 2 raised to the power n. And 2 raised to the power n is equals to total number of registers in the system. Number of inputs in ALU 32, because the size of the number of multiplexer is equals to 32. So that is why 32 for bus A, 32 for bus B, and 1 is the input carry. So total I am getting is 65. Number of outputs in ALU. So 32, that result I am getting, and 1 is the output carry. So it is going to be 33. And how we design the control word? So it is first one is select A, that is select bus A. So how many selection lines are there in each of the bus? 4. So 4 bits will be required. For select B, again 4 bits will be required. Select number of select line, right? Then select destination. So this will select with the help of the decoder. How many inputs are there in the decoder? 4. So again 4 bits will be required, and total operations are 35. So I need to use 6 bit to specify the operation. So here I am using 6 bit of the ALU operation. So total number of bits required is going to be 18, right? And this is the configuration. So here we are having ALU. This whole system is actually for bus A. This whole system is actually for bus B, right? Here input carry we are getting, then ALU perform the result. It will generate a 32-bit output along with one output carry. So 33 bits it is generating. And where these 32 bits will go, it will be decided by this select destination decoder, right? So on the basis of value of these decoder, these 32 bits will go into one of these registers. And how many total registers are there? 16. From R0 to R15, right? So this is how you can solve any common bus problem system using multiplexer. So in the next lecture, we'll discuss how we can use tri-state buffer to design a common bus. Thank you.